So we will continue today's class with numerical phenetics. On a sheet of paper, please write your name just for attendance. So the first thing which you must study is unit characters. Now all these references which is based on the book from SOKAL and Sleep 1963. This is a good book on numerical phonetics. Since numerical phonetics nowadays is not used very much, so it is not. You don't have any recent books on this. So unit characters, they are basically defined. They are taxonomic characters. Taxonomic characters of two or more states, and the important analysis is within the study cannot be subdivided logically. So this is the definition of unit character. It cannot be subdivided logically. This is the most important term. It cannot be subdivided. For example, you can divide your hand into 5 fingers. First finger, second finger, third finger. But from externally, this finger cannot be divided. If you cut this finger is cut. So you must consider this to be a total, the smallest unit you can take. Within this particular study, I am talking about fingers on a hand. My study is presence of 5 fingers or presence of 4 fingers. So when I am in my context of my study, 4 fingers or 5 fingers, 1 finger is actually the unit character. It cannot be subdivided. You cannot say it's half a finger. You say 4, 5, 3, 2, 1. So this is basically, this is the definition of unit character. You cannot? Huh? 2 or more states. 2 states, 1 state. State is a particular character. Say for example, presence of wings, absence of wings. These are the 2 states. Yes, sir. Presence of here you may have in a 5 fingers, when your 5 finger is the maximum, presence of fingers, there are 5 states. 1 finger, 2 fingers, 3 fingers, 4 fingers, 5 fingers. 5 states are available, 2 or more states. Next part is binary character. Now binary characters, as the name says, they are also unit characters which exist in two states. Binary characters which exist in two states. Now we are talking about numerical character. So there is a term which you use, coding. This means you are converting a character into either a number or symbol. It is very much used in marketing, finance and taxation, where a particular character is converted into a number. So these numbers are two states and you give them a simplest form of coding, either plus or minus, present or not present, or you can give it 1 or 0. Bolo. Bolo.
তোমার বলে একটা ফার্স্ট ইয়ারে ক্লাস করছেন দেখে এরকম খাচ্ছে ওটা কিন্তু কোডের ফলস
আছে না
কোডের থেকে নেওয়া হয়েছে অ্যাডমিশনে মানে দিচ্ছে ডুপ্লিকেট।
আচ্ছা,
আর ভেরিফাই করে দিয়েছে পি দত্ত না অন্য ভেরিফাইড বানান লিখেছে, ভেরিফাইড বানান 29 জনের সাথে পড়েছে এরকম 2,06,700 টাকা অ্যামাউন্ট আছে।
এরা হচ্ছে ফেক লোক, এতগুলো ওই অনলাইনে দেখো অ্যাডভান্টেজ নিয়েছে। না, এটা তো অফলাইনে হয়েছে।
মানি রিসিপ্টটা বার করে এডিট করে করেছে, মানি রিসিপ্টটা এডিট করে
এদেরকে বের করে দিতে হবে।
আমি বলে দিলাম ওটা যেন ক্লাস না করতে হবে, তাহলে আমারও লাইব্রেরি চলে আসবে ক্লাস করাচ্ছে।
ঠিক, বদমাইশ। এই আমাদের মানে 2 নম্বর দেশটা পুরো। Okay, so these are actually the two states, simplest form of coding, plus or minus, presence of which, absence, only 2 states, presence, absence. Here there are 5 states. This is not a binary character. My fingers are not binary characters, right? So this is the simplest, 1 or 0. This for example, male or female, 1 or 0. Males are assigned 1, females are assigned 0, or males are assigned plus, females are assigned minus. So you are seeing the text. So like this is called coding. This is used not only in biology, it's used in a lot of finance, taxation, statistics. In statistics, when you use software SPSS, this coding is a very important part. Okay. Next comes so numerical phonetics of first state. You have binary characters, very easy. Plus, minus, you can say, and things are done. But life is not so easy. You will always have something which is more complex. You have multi-state characters. You have multi-state characters. Now, what are these multi-state characters? As the name suggests, these are the unit characters which exist in more than two states. Unit character, it cannot be subdivided logically in that particular study, right? Unit character which exists in more than two states. Unit character which exists in more than two states. Very simple, your hand, multi-state character. Subdivide logically in that study. When you are talking presence of fingers, you cannot divide a finger into half a finger. Multi-state chain. This is the example of your hand. It's a unit character, types of unit character. One is binary character, one is multi-state character. Now we are going to divide multi-state character. You can divide this multi-state character into qualitative and quantitative. You can divide them into qualitative or quantitative. Qualitative, they contain three or more contrasting forms. I'll explain what they are. Next point is, each form is ranked on equal footing. Each form is ranked on equal footing. Example is flower color. It can be white, red, purple, etc. Different colors of flowers. It's a quality. As the name says, it's qualitative. You can have three or more than two. That is three or more. It should be more than two. Because multi-state, two हो गया तो it becomes binary character. So this has to be more than two. Three or more contrasting forms. Each form is ranked on equal footing. That is, purple has got equal value as red. Purple is a different color, but if it's purple, it's purple. If it's white, it's white. Purple given 1, white given 2, maybe what was the other color? Red given 3. So whenever you see purple, 1, whenever you see white, 2, whenever you see red, number 3. You put those. So this is qualitative, quality कौन सा quality है? Red quality का है, ये purple quality का है, something like this. And the next thing is you have quantitative. They represent measured They are continuous. Example is, say, length of leaf 2 centimeter, 3 centimeter, 4 centimeter, 3.5 centimeter. You can go accordingly. These are quantitative multi-state characters. These are quantitative multi-state characters. So it is continuous. A leaf can be 2 centimeter, 2.1 centimeter, 2.2 centimeter, 2.15 centimeter. So it's on a continuous scale. It's not discrete. So this type of a character, oh, it's a 2 centimeter leaf, 2.5 centimeter leaf, it's a 3 centimeter leaf. This type of character, we are quantifying the length. On the basis of this is quantitative multi-state character. Now, Sokal and Smith, they gave certain rules on proper selection of unit characters. Proper selection of unit characters. First is they should come from all parts of the organism. So essentially what you are doing, you are trying to group. So these are the different steps you are going. You are trying to group them on the basis of similarity or dissimilarity. So if you take a flower of a plant, you can take a leaf of a plant, you can take a root of a plant, you have to compare it with all the different plants. So you should get a similar result. That is the best unit character you can take. They should come from all developmental stage of life cycle. Different cycles. For example, Axidia, it is a type of chordate. In the larval stage, it has got a notochord with tail. Therefore, it is a chordate. But when it becomes an adult, it loses it. Although they are placed in the chordate, they are not compared with chordate, because at one developmental stage, they have got when they are larva, they have got a notochord. Therefore, they are chordate. When they are adults, they don't have this. It's a retrogressive metamorphosis in Axidia. Please to study. Maybe you people also will have to study that. But because of this reason, it cannot be considered to be placed exactly under where I am placed. It has to be placed separately. Urochordate. That is, uro means tail. They have got a notochord in their tail. They are called urochordate. So Like that, it should be from different parts also. Parts are taken, now you are taking different life cycles. Third is, variable characters within the group should be used. Very important. Variable characters within the group should be used. Now, you are looking at group, you are taking the group is, say for example, mammals. Now, if you say presence and absence of head, all of them have got head. It's a constant character. So, your head doesn't become a unique character. You have to find out something else. Wings, your limbs modified. Maybe you take limbs. In one it's wings, in one it's moving, in one it's for keeping and crawling. So in one has got 5 fingers or 6 fingers. So you have to take unique characters like this, which is variable among that group of all the mammals. If you say head, all the mammals have got head. If you see mammary glands, all the females of the species have got mammary glands. If you say hair, all of them have got hair. So these are not variable characters, and so they should not be selected as unit characters within that group. But if you subdivide it, hairs modified into so, hairs modified into so. There are rhinos, it is modified into a horn, the hair. So yeah, you don't do it. And the fourth is, due attention should be given to characters on the basis of morphology, physiology, ecology, and distribution of the organism. Related to morphology, physiology, distribution, of the organism, and ecology. These characters have been given importance. Nowadays, numerical phenotype, it is totally quantitative, because you talk about protein, DNA, sequence, nucleotide, that's the ultimate proof. This was older times, so these 4 things have been given weightage. So according to Sokal and Smith, these are the criteria for proper selection of unit character. Which unit character you must take. Today we will be talking about one method it is one numerical method to estimate relationship between taxonomic groups. Resemblance, let's say resemblance between taxonomic groups. This is one way. So you see, if you use numerical method, the numerical score will be high when there is similarity. Numerical score will be low when there is less similarity between two groups. You are now quantificating the number of characters. And the first is coefficients of association method. This is the you use coefficients to say how similar or how different they are. Now, last year we had talked about operational taxonomic unit. That is, it can be either a class or a order or phylum. These taxonomic units are known as operational taxonomic units because you are operating with them, you are working with them. And characters, 4 characters we are taking, 4 unit characters. Characters 1, 2, 3, 4. 4 characters. Operational taxonomic unit I. This is the first OTU. These are the assumptions I am saying. OTU J. This is the second OTU we are talking. If there is a match between a character 1 is present in 1, match. This is a mismatch, it doesn't match. This is a match. Anything else I am missing? Mismatch is labeled as U. Match is labeled as M. Now I am drawing the simple matching coefficient. SM, simple matching coefficient. Some people call them as numerical index. Some call it as simple matching index. Some call it a simple matching index. Some call it just like coefficient. Now if I draw characters 1, 2, 3, 4. 4 characters. Maybe one is presence of wings, one is presence of limbs, one is presence of hair, presence of something. 4 unit characters we have selected. This is OTU I, first taxonomic group. OTU J. Now, say for example, character 1, it is present here. Maybe limb, present in I. Limb, it's absent in J, 1 character. Similarly, maybe head, 1. It's present in both. minus. It's something, some other character not present in both, and plus. So you can see these are mismatches. It's present in one, it's present in the other. These are mismatches. So number of mismatches, formula is SSM coefficient so M is equal to matches 1 and 2, two matches present. This is a match, this is a match. Mismatch 2. So what is the coefficient? 2 by is equal to 0.5. Fine. So there is a 50% match, 50% mismatch between this group. So this is a very easy statement. You can have 5 more characters. 3 may match, 2 may not mismatch. So very simply you put them in this formula and immediately you will get you can, from this number you can see which is close or far away. 0.5 is 50% match, 50% mismatch between these two groups with binary characters which we have done. So today I will stop over here, otherwise it will become an overdose.